Hello and welcome to this webinar on Customising the Toolbox with me, Miles Briney. So first off, we're going to go and load SolidWorks. Okay, so we've loaded SolidWorks up. To turn the toolbox on, I have to go to Tools, Add-ins, and then select the toolbox and the toolbox browser. Now, the buttons on the left here select that the toolbox will be opened just for this session of SolidWorks. If I want the toolbox to load every time I start the program, if I tick these boxes on the right hand side here, it will start it on startup. So after that I'm going to go OK. That's going to load the toolbox in. If I go to say File and then New, and let's just make an assembly and go OK, I'm just going to exit the Insert menu. Okay, and if I go to my Library tab on the right hand side, you can notice the toolbox is now available from my tree on this side. If I expand it, I've got a number of standards that are in here, and the idea is I can click on a standard, say let's have a look at ANSI inch for instance. I can then click on bolts, countersunk head bolts, and then I can select the type of hardware that I want, in this case this countersunk bolt, and then I can just drag them into the screen. So if I just drag it in, there's my countersunk bolt gun has gone in. Now there's a number of properties that I can change here. These are all to do with the size. So there's a number of different lengths and sizes that I can put on here, as well as how the thread is displayed. There's simplified, cosmetic and schematic. If I change them, it will show. So simplified has nothing shown. Cosmetic is, if I just change the length so you guys can get a better idea of what it looks like. There we go. So cosmetic will show just a decal of what a thread looks like, and schematic will actually add on a cut onto our bolt. So it's just a revolved cut. It's not actually a proper thread, it's just revolved to give the appearance so it looks like a thread. Size wise, simplified is always the lightest. Cosmetic is also inherently quite light in file size. Schematic is about 30 times larger in file size. So if you've got a lot of these added in, it will slow the rebuild and loading time for assemblies if you've got them all on schematic. Okay, so we'll just go OK. That will then add in my toolbox component into my assembly. Now I'm just going to go ahead now and show you how you can configure your toolbox. And to get to the configure window, if you go Toolbox from the top here and then go to Configure, you'll then get the Configure hardware box up here. It's a slightly different program. It is independent of SolidWorks itself, and this customises the back end of the toolbox. So there's five different tabs that I can select in this customized toolbox window. So I've got Hole Wizard is the first one. So what standards are shown in the Hole Wizard. Customize your hardware, so what standards are turned on and what hardware you've got turned on. And also I can customize things like sizes and any other options that are available for those parts. I can also create custom properties for existing parts in the toolbox and add other custom properties like a description or maybe a part number. Okay, after that we've got Define User Settings. This is to do with how toolbox components are created. After that we've got Permissions, so how people can access this window itself. The ideal way would be to put a login password onto this window, which I'll show you a bit later. And the last one is to configure smart fasteners, so washers and smart fastener itself, regarding auto sizing, and how the top stack and the bottom stack of washers, so nuts and washers, behave. So let's go ahead and just have a look at number one first, which is the Hole Wizard. So at the moment I've got all the standards turned on for the Hole Wizard. So let's just go ahead and have a look maybe at the ANSI metric. settings. So I've gone into the standard ANSI metric, and we're going to go into counterbore. Now in counterbore there's a number of different counterbores I can add in using the hole wizard. This, for instance, have a look at the hex screw type that I can add in. In here there's a number of different sizes and options that this particular hex screw counterbore hole has. I can modify these in any way I want, and then they will affect how the hole is put in if I select that option. I can also add a particular size in if I want. I'm not going to bother in this instance, but I will show you how to add in a size on a piece of hardware later on. So I can add my own sizes on. Now that's new in 12. You never used to be able to do that in say 11 and before. So it can be quite handy, rather than taking hardware, in this case, or hole wizard settings, of taking hardware settings out of Toolbox. You can just configure existing components. Okay, so another thing up here I'll just bring your attention to is the type of Toolbox hardware that is actually added in if we was to select smart fasteners after we put our hole wizard hole in. And at the moment, for this particular hex counterbore, hex screw counterbore hole, at the moment it will add in a hex screw _ AM part. So that's a Toolbox part it will add in automatically. Now I can reassign it if I want by clicking the reassign button here and then selecting a different hardware selection for it. So if I do want it to always populate with a different Toolbox part, I can. So let's go ahead and just minimize that back down. Let's go back and click on the hole wizard standard. So I'm just going to leave all the standards on for that. If I do want to turn some of the standards off, say like I want to shorten my list in the hole wizard and tool, I can turn say some of these off, and they will then, if I click save, I won't do it just now because it will close the window, but if I click save, they will no longer be available, those standards. I can also do it for particular types of hole. So if say I didn't want DIN counterbore holes to be available, I can turn them off. Note when I turn options off which are in subfolders from the top level where the standard folder is, instead of having a tick, it's now turned into a blue square. That's to show me that some options further down, so some subfolders or parts maybe, have been turned off. Now if I untick this, you'll notice that the entire DIN standard has now been turned off. If I tick it again, it's now turned the DIN standard on. If I click in DIN standard, you notice that counterbore has now been turned on. You'll now notice that counterbore has been turned on. So this is like a global setting here to turn either everything off or everything on. Right, let's have a look at number 2 now, which is customize hardware. Now at the moment in here I've got practically everything turned on. What I can do is just say I go into ANSI metric, let's have a look in here. Let's have a look in washers for instance. And I'm going to have a look in plain washers, and let's just say regular flat washer. That's going to build the list for me. So for this regular flat washer, I've got a number of different sizes that are available here, which you can see. There they are. If I do want to change or add any sizes, any particular settings, I can click on size here. At this point I can change say one of the sizes here, and it will update in my list down here. So I can't actually edit any of the sizes from this window, but I can add part number, description and comments on. So these are custom properties that exist for every configuration, because remember this is one Toolbox part, and here are all the different configurations that are available for this Toolbox part. And because you can have custom specific properties, so because I can have configuration specific properties, it allows me to add in a part number description for each different size washer, so every configuration that's available for this particular Toolbox component. Now I can add in my own one if I want. So let's say I've got a particular washer that is actually very similar to a regular flat washer, and I want to add it into this standard. Say I use my regular flat washers from the anti-metric standard all the time. I don't want to have to switch between, say, a custom standard that I've created. I just want to put it in here. I can click the add button here. I can add a new size. So let's say, for instance, my size is 40. So my inside diameter is going to be, say, 41. My outside diameter is going to be 55, and my thickness is going to be, say, 7 mil, and go OK. So that size record has now been added in. That has also been added into the bottom list here. So that then allows me to put another part number and description in for it. Now, if you're using these components regularly, so they say this toolbox washer quite a lot, it's always recommended that you fill in a part number and description for that component, or that configuration, should I say, of that component. Mainly because if you obviously add these into an assembly and then you create a drawing from that assembly and put a bill of materials in it, you'll want to you want the part number and description to be displayed in that bill of materials table. If these are empty, it won't display anything. Obviously that's no help to anyone who's maybe going to build the assembly, or is, say, someone in purchasing that needs to order in a certain number of these washers in this instance, to make sure when you do come to build it, there's enough available. Other than that, other than size, there is a colour setting as well. When I add it in, I can, at the moment it's on the default colour, I can tell it to have a specific colour setting. Custom properties, I've already got a custom property available to me, which is called test, which I put in a little while ago. I can add in my own custom property. Let's call it something else, like let's say material, and go OK. Now if I click on add as configuration specific property, it will add that into it will add a box in for every row I've got. If I untick that, I'll only be able to, it will be a global setting that affects the entire part. So I'll just leave it on as a configuration specific property and go OK, and then I turn it on. You'll now notice that the material setting has now been put in. If I edit it and then untick this and go OK, you'll now notice that that has now been removed from each row there. That means I can put an overall default value in, and that will display for each time. So let's put steel, for instance. Now that will be added in. Okay. Next off, I'm going to have a look at, let's just go back to the front. So this is the front on that page. So I've got my anti-metric standard turned on, which is good. Next off, let's have a look at the user-defined settings. So there's two things in here that are important, and that's how when you drag in a toolbox component into an assembly from the right-hand side window here, how it builds that size of that component you're adding in. So say I dragged in my washer and I selected, say, an M10 washer to be put in. If I've got it on create configurations, what it'll do is it will open the toolbox component where I'm dragging from, so in my toolbox location, which I'll get onto in a second, and it will add a configuration in for that toolbox part. So it will add an M10 configuration into my toolbox part. If I've got it on create parts, what it will do is it will, when I drag it in, it will go and have a look at the information it needs to create that M10 washer, and it will create a new part which will be under whatever this folder is set to here. So I've got a folder that's called, in my C drive, called Toolbox Parts. It will go and then add in a new toolbox component into this part, which is specific for that M10 washer or whatever I've selected. Now you may ask which one's better. If I'm creating configuration for some toolbox parts, you may find if you use that particular, say it's a bolt for instance, you may find it has overall, if I used every variation of it, there may be 3,000 configurations for it. That means when I go to load it, say I open an assembly and that bolt's in it, it's going to have to load that bolt file into SolidWorks, because for instance say there was a couple of thousand configurations in there, it may be a very large file, say like 30 meg for instance, whereas if I'm creating them an individual part for every configuration there is, you may find that it's only like say 200-300 kilobytes in size, which is a lot smaller. Takes less time to open, but every time I drag a component in, if it hasn't made it already, it takes slightly longer because it has to make the part and then go and save it somewhere before you have access to it in the assembly. So it swings and roundabouts which way you want to go about it. If you've got a toolbox component that you're only interested in, say like maybe 4 or 5 different configurations for, then maybe configuration specific would be better. If you know you're going to, there's a lot of configurations that you're going to use for that specific toolbox component, maybe creating individual ones is. Or you can have a bit of both. If you put create parts on control drag, if you use control drag, it will create a file from the, you'll create a new toolbox file and put it into my folder. A standard drag in from the right hand side would be to add a configuration into the master toolbox part where the original file, toolbox file is. Okay, so we're going to have a look at the permissions tab now on the configuration, toolbox configuration. So in here the main thing you can do is to add in a password. Now the main reason you do that is so if you've got a centralized toolbox, what you do to stop people editing the toolbox is to put a password on it. So if I create a password here, if I for instance call it password, and I can just leave these to make it blatantly obvious what the password is, so password and password, and go OK. Now once I've logged in, at the moment all these are, I can edit all of these, so the content, any custom properties for the parts, any toolbox parts themselves, part numbers for the toolbox parts, and the configuration name and file name. Now if I want to untick these, I can do, and then if I save this and then close it, it means that I'm going to have to log in again and then tick these before I'm able to change them. Okay, so if I just save this for instance now, and I close this, and then I'm just going to go toolbox and then configure again, and let's go and have a look. You'll notice that everything's greyed out now on here. I can't tick these on and off. That's because these are all unticked, so I'm going to have to log in before I can use them again, so I can start editing the toolbox. At this point I can turn them all back on, and then that allows me to edit them. Okay, another thing is the user settings. So if I've got it set to separately for each user, for user settings, it means that some people can have different standards turned on or off to other users. If it's the same for all users, and everyone has a uniform set of standards that are either on or off. Same with smart fasteners as well. I can say turn specific standards off of smart fasteners and no one has access to them if I tick this box. If it's on separate for each user, they can change if it's ticked for them here. Okay, lastly let's have a look at number 5, which is smart fasteners. So we've got washer sizes to start with. So show washer sizes that match fastener criteria. So for the fastener, it's either going to at the moment it's unrestricted, that's by default. I can put it on an exact match, so if the washer size is, say if I'm looking for an N10, if the washer would have to be an exact match for that M10 bolt for it to then put it in, or if it's a greater than tolerance, so if it's 20% larger than the bolt diameter, for instance, it would then add it in or give you a choice. Unrestricted, it can just pick the nearest size for it. Automatic fastener change, so if I tick these, so it will automatically change the fastener size to ensure that there's a minimum thread engagement. So it's 2 threads beyond a nut, or 1.5 times the diameter into a tapped hole. Right, the last one in here is stack components. So when a fastener size is changed, it can automatically change the stack components with it. Lastly, if you've got non-hole wizard holes, so extruded cut holes for instance, I can select a specific socket head cap screw to be added in. I can change this to anything I want, to be honest. It's just going to say if I select Smart Fastener for it and it's non-hole wizard, it will just add this one into it. Okay, so that's now my toolbox fully configured with a password as well. If I close this now, let's just go and add in, just to prove that my washer I made does exist. Let's go and add that in now. So let's go and find it. So there's my regular flat washer. If I drag this in now, just wait for the settings to then load. I then can go and select my M40. There it is. Go OK. And there's my washer added in. Right. Let's just have a look at the toolbox location. So I'm going to go back to, if you need to know where it is for your specific SolidWorks installation, go to the hole wizard / toolbox option in options, which you can get to from this button here. Now at the moment mine's a local copy. I do a lot of work, say out of the office or where I'm not tied directly into our server, so that means I have a local toolbox. So I normally do it, the default location is SolidWorks data. I tend to add in the version name after the standard SolidWorks data, so I know what toolbox is for what version if I've got more than one installed. You also tick this that says make this folder the default search location for toolbox components. Now what this does is it adds in a search path to, I'll show you where that is. So if I go to file locations and I go to search paths, so there it is, you'll notice that C SolidWorks data 2012 is added in. Now the reason it does that is if someone, say you've got two people in a design office, they're both working locally, dragging components in from their own toolbox, but the file names where those two toolboxes are stored are different on each machine. When you go to load an assembly, it's going to go and try and find it at whatever data location that toolbox, when the assembly was made, where that location is. If it can't find it and I've got no other search paths available for me, it will pop up with a box saying I can't find this toolbox component. You're going to have to locate it for me where this part is. If I've got that option ticked here, what it'll do is it will go and have a look in my toolbox folder first before it prompts for me to go and find it. So it's not too bad if I've got one washer in it and I have to find that one washer. If I've got 50 toolbox components in there, it can become a little bit tedious. So by ticking that, just removes, it will search in this location before it prompts you to find it. Now that's another thing. Notice mine's on the C drive, so I've got a local copy. If I wanted, normally large design offices would have it centrally, so you know everyone's got a uniform toolbox. So if one person opens, makes an assembly, drags parts in, saves that assembly, checks it say into a vault or saves it on a server, when someone else opens that assembly, they'll go and look for the toolbox components in the same place, and you know they're all going to be exactly the same. The only downside to having a server on the server is it may take slightly longer to load an assembly, especially if you've got a lot of toolbox components in it, and especially if those toolbox components have a lot of configurations. If the network is slow, if you've got a slow network, it may take time for it to pull all that information onto your own machine before it can open it. So having it locally does help. Another thing obviously good about having it on a server is obviously normally servers get backed up, so you've got redundant files. If for instance someone accidentally deleted something or changed something, then you can change that. You can then replace it with a backed up version. Okay, so that's the data location taken care of. I'm just going to show you one other tool now. So if for instance, I'm just going to delete these two components out of here. Say I want to create my own custom standard. There's a number of different ways you can do it. You can either make it in the toolbox, or you could do something slightly similar, which is a design library. So if I go back and say configure my toolbox, and I'm going to go customize my hardware, I can, for instance, add in, say I use the ISO standard quite a lot, I can right click on the ISO standard, right click here, and then go copy, and then right click on the top and then go paste, and then it's just copied the entire ISO standard into another folder here. In this stage I can then delete everything I don't want, like so, and then I can start adding in my own bolts if I wanted to. So let's say this, add in a new folder into here, and then let's call it maybe custom bolts, like so. And at this point I can go and add in a new file here. So right click and go add file. Let me just go and find the file I want. So I've got a folder here that's called custom bolts. I'm just going to go and add in one of my custom bolts here that I've made and go open. It will now add that custom bolt into this folder. So that's one way I can add an existing folder into a standard I've copied, and then add in my own hardware for one. I can add them into any folder that's already existing here. I don't have to make new ones every time. At this point I can save it, it does take a little while because it's going to add in this hardware into that standard I've just made. Obviously it's got to make an entire set of new parts for this ISO 1 standard I've made. And at this stage, if I just close this and I go and have a look in my toolbox now, there's my ISO 1 standard that I made, and if I go into my bolts and then select custom bolts, there's my custom bolt that I made earlier. Go OK, and then it's added that in. There we go. I'll show you another way you can do it now. This way is for when you want to have your own design library parts, but you don't want them to be checked into, say, a vault. Now so obviously a vault's part of either workgroup PDM or enterprise PDM. There's something that's added to toolbox components. If you notice here, it's not coming as a part because I've added it into the toolbox. It's now got a Toolbox Flag added to it, which shows up in assemblies as a bolt symbol here. So it doesn't look like the standard T-shape that you get for the T-shaped block that you get for parts. So what I can do is I can add my own design library in instead of having it in the toolbox. So at the moment I've got a number of design libraries here. I can also add my own design library. So I'm going to add a file location for my design library, just call it custom bolts, and go OK. So there it is. I've got two bolts in here at the moment, but at the moment they've got no toolbox flags added to them. So to make sure I get a toolbox flag added to it, I'm just going to delete this bolt out of here because I don't need it anymore. If I go and find those two bolts, so here they are. If I go and use a specific utility that SolidWorks provides you with, I can add a Toolbox flag onto those parts, and that will mean when I go and check in, say, an assembly into my workgroup bolt, it will not check in those Toolbox components. So let's go and find that now. So it'll be under Program Files and then SolidWorks Corp. I add another folder name into my installation. Yours might not be there, it may just come up with this. If it does, then look for SolidWorks, Toolbox, Data Utilities. It's called Solid Set Document Properties is its full name, but in here it's just sld.set.prop.exe. If I double click this, it'll bring up this window here. And now what I can do is to add a flag. So either turn a flag on, so add a flag, or no is remove a flag from a Toolbox component, an existing Toolbox component. So say I've made a part which I want to add into, say, a design library for instance, but I don't want it to ever get checked into a vault. I need to make sure the flag's added in, so that's what I'm going to do now. So I'm just going to click here and then go add files, and I'm just going to go and find those two bolts. So I'm just going to select both bolts holding down Control and go open. It's now added those hex bolts into the tool here. If I put it on yes and then go update status, notice you get no prompt for it, it just does it quite quickly. If you've got a lot in there, it may take a couple of minutes to go through and add the flags in to each part. At this stage they've added them in. Obviously, yes, as I said before, yes is to add a flag. If I've got for instance, I've got a Toolbox component, if I add it, say, drag it into an assembly and then open that part and then do, say, a save as copy and then save it somewhere else, it's always important to remove the Toolbox flag if you want it to be an independent part in its own right again. You may find if you don't remove the Toolbox flag from it, and you have taken it out of, say, the Toolbox, that's where you've got it from, you may find if you start editing it and then save it and close it, after a while it may flip back into its original form. So it's important to remove the Toolbox flag when you want it to be an independent, say, like a library feature, that you do want to check into the vault. So in which case you put it on no. So I've selected these two, put it on yes, update status, and then that's added the flag in. If I close that now, what that means is when I drag in, if I go and find SolidWorks and then select my design library, when I drag these two in, it's going to make sure a flag has been added to those Toolbox, these custom parts, shall I say, that I've made, and that means when I go to check them into PDM, they won't get checked in. Okay. As you can see here, this was an original part that I've made from scratch, and because I've added that Toolbox flag onto them now, it's now added their Toolbox flag onto it, so these will not get checked in. Thanks for watching.